Today we will look into another interesting item from effective Java. This is regarding using overloading judiciously. We all have used overloading and overriding in our projects. However, when I gone through this item, I was really surprised by seeing the aspects which we need to take care, especially when we are designing our APIs by overloading the methods. Let's see these aspects by going through some examples. Let's consider this example of collection classifier. Here intention is to print the individual type of the collections of this array using this classify method. So as you can see, the classify method is overloaded and which takes the different types of elements and it returns the corresponding type. So what do you think? What will be the output of this? Let's see. Surprise. So for individual elements, it's printing unknown collections. Although the individual types are hash set, array list, or a list of values, it is printing unknown collection. Why so? That's because overloading just cares about compile time type. It doesn't care about the runtime type. That means although the individual types are different, the compile type of these elements are collection. Hence, it is going to call the classify method which takes the type as the collection. So how we can resolve this issue? Well, one of the approach could be in the classify method, you use the instance of operator depending on individual type of the element, you return the corresponding value. Let's see how this will do. So this is printing us as expected set list and unknown collection. Going back to the original program, here there are some quite a number of issues which we need to take care, especially with respect to overloading. Let's say the classify is an API which I want to use and I'm calling the classify method with a particular collection. It is not obvious to me that which method will get called. That's because the classify method, all the three overloaded classify method takes the same number of arguments, here single argument. So one of the highly recommended approach in effective Java is avoid having overloaded methods with same number of arguments. Overloaded methods with same number of arguments creates confusion for the consumers of the API. So how we can avoid it? Let's see some of the examples from JDK itself. Let's consider the class object output stream. It has quite a number of methods and we'll see these methods like write byte, write char, and there are few methods like write itself with byte array. As you can see, if I am calling any of these methods, I am sure that what it is intended to do. If I am calling this write method, so it is taking byte array. If I am calling this write method, so it is taking a different number of arguments. If I am calling this write method, it is taking integer. So this write and this write are, although they are taking a same number of arguments, but the arguments themselves are totally different. And here the method name itself is meaningfully named write char. So I know that it is going to write the character. So one of the approach is to have a meaningful names rather than overloading. If possible, we can use the meaningful names. If it is not possible, then we can have, like in this case, totally different type of argument. Byte array is not same as int. So this is one of the best approach to avoid or when we have the overloaded to have the different types of arguments. And one of the advantage with this approach is if you go to object input stream, Since we have write methods in the object output stream, we can have the corresponding read methods with the similar consistent naming like read byte, read char. Let's see another aspect to overloading. Let's consider this example. Here I am printing a set and a list by adding some values here. So here I am adding some consecutive integers. Here I am removing some consecutive integers. So basically I am doing the same operations on the set and list. And what I am expecting is it should be printing the same values for set and list. What do you think? What it will print? Well, let's see. So for set it is printing -3, -2, -1. For list it is totally different values. Why so? Let's see. If we get into this method of remove in the array list, so as you can see in the array list we have remove method with the type int and object. Which method will get called in this case? It is integer, right? So int. So when it calls int, as you can see, although it takes the integer as an input, it is index of the element, it is not the value. That means when it calls the list dot remove with I, let's say initially the I0, so it will remove the element at position 0, like this one, right? So in the next iteration I is 1, then it removes the element at index 1. In the same way, in the next iteration I is 2, then it removes the element 1. That's how we are getting a different value. So this is one of the issues with auto boxing. Earlier to Java 5 it was evident that which type we are going to call, but with introduction of auto boxing, so we need to be careful when we are making call to some overloaded methods, including some of the APIs in the JDK. So how we can avoid this? So here one of the way to avoid this is to call the integer with casting. So as you can see here, we are getting the values as expected. Some other aspects to overloading. So there will be some use cases where we cannot avoid the overloading with same number of arguments. For example, when we have the constructors. So there could be cases like where we have the same number of arguments for the constructors. So in those cases, what will be our approach? Let's consider the class array list and the constructor of array list. So array list has these three constructors. Let's consider these two. Array list which takes the input as collection, and another one which takes the input as int. So although the number of arguments are same, the argument types itself are totally different. So when I'm making a call to array list with one of these constructors, I'm very much clear that which constructor will get called. So this is one of the recommended approach. When we have the same number of arguments, it's better to have the argument types to be totally different. They should not be descending from each other. We should not be able to cast them from one type to another. This is one of the best approach to have the overloaded methods in a constructor. Let's consider another example wherein we cannot avoid the having the overloaded methods with same number of arguments, and the arguments themselves could be descendant of each other. In the string class we have method content equals which takes single argument and one of the overloaded method takes char sequence and another takes string buffer. In those cases, it is recommended that one of the methods which takes the generic input should be implementing the original logic, and the other remaining overloaded method should be calling uh, the other generic method using the method chaining. So how is it done in string? As you can see, in content equal, the string buffer method is calling the other overloaded method which take the generic input content equals, and here we are casting the string buffer to char sequence. Basically, when I'm calling either of the methods, either of the content equals method, the expected behavior is same. So point to note here is, when we have this kind of scenario, we should be implementing the methods in such a way that if a developer calls either of these two methods, the expected output, the behavior should be same. So this is one of the approach. So it is better to avoid this kind of situation. If at all we cannot avoid, we have to follow this kind of rule. So I hope this item is clear about overloading, and this was quite a surprise to me that overloading has these many aspects to it. And I will see you in the next item. Thank you.